course about the mechanical works. What I have covered is the first thing is about the introduction. In that, I have explained what is the MEP works. MEP is basically mechanical, electrical, and plumbing works, and how much it contribute to the total building construction, and all this thing, all the details, it is there in this course. The second lesson is about the mechanical works, the technical study of the mechanical works. In that, we will see uh, how you will learn what are the type of ducts to be used, what is the type of AC units used. So all these technical details, which is related to the mechanical works, you can learn from that lesson. The next one is about the bill of quantity, about the mechanical works, how to prepare the bill of quantity, what are the sections it is there, what are the divisions it is there for the BOQ. So all these details you can learn in this lesson. The next lesson is about the complete plant physics training, and that you can learn how to take the quantity for the pipes, ducts, sprinklers, all these minute details, all the details which is there for the mechanical drawings, you can learn from that lesson. The next one is about the mechanical cost sheet, which include the indirect and direct cost. So in the construction, there is two types of costs. One is the direct one, another one is the indirect cost. So what are the things which is related to the direct cost? It can be in the terms of material, in terms of labors, in terms of installation, in terms of machinery. So all this comes into the direct works. And there is so many indirect costs also it is associated. It can be the salaries of your employees and any indirect costs which can be associated for the projects. So you can learn what is the difference between the direct and indirect costs associated for the mechanical works. The next one is thumb rule for the QS works. Thumb rules it. Sometimes we don't have the quantities for many items. So how you can estimate quickly for a mechanical works. It depends on based on the build-up area, based on the tonnage, based on the linear meter of the pipes, based on the square meter of the ducts, how to calculate the total value of the mechanical works. This I have explained already in my lesson. The last one is about the value engineering, which we will discuss in this webinar. So all this, what you can see in this list, it is there in my course about the mechanical works. So we'll just quickly see about a value engineering. So what is the value engineering for the mechanical works? So I'll just quickly go to the slide for the value engineering. So anyone can I just want to interact you also with me. So anyone have any idea what is the value engineering in the construction? You can put in the chat, or if you want, you can say also. It's fine. Anyone, if it is wrong also, it's wrong, no problem. I will learn from you, you will learn from me. So anyone who has any
Reducing
idea
the
about value engineering?
cost, reducing
Yeah,
the
please.
cost by complying the specification.
Reducing the cost by complying the specification.
Complying the specification, alternate suggestion, which complies the specification.
Yes. It's partially it is true. So reducing the cost. So we got one answer, reducing the cost. Anyone else?
Reducing the cost without compromising the quality of the work.
Exactly. Yes. Very good. Two answers we
Meeting
got.
the
First,
timelines.
I'm
Meeting the
sorry.
timelines. Meeting the timelines.
Meeting the timelines.
Using alternate
Okay.
materials, which reduces the
Al-
cost.
Yes. Alternate material, reducing the cost by not compromising the quality. So many answers. Good. So actually, value engineering, it's a combination of three things. First one is increasing the value. Second is lowering the cost. The third one is maintaining the functionality. So it's a combination of three words. The first is increasing the value. So how, if you go in a flat, if you're buying a flat, okay, 1-bedroom apartment. So as a customer, what you see, what you want a cheaper value. You will look for the amount. Okay, it should be my budget. It's like a 1 million dirhams. So I want anything in between maybe 900,000 to 1 million dirhams. Okay, so this is the first thing, increasing the value. How I'm increasing the value? That as a customer's perspective, I need a cheaper one. Lowering a cost. How you can lowering the cost? The total project value, the total construction cost should be reduced. Okay, so how it can be reduced? It can be reduced by proposing an alternate materials. And like for the pipes, I'll take an example for the pipes. If in a specification, if a client is asking to use a copper pipes for the water supply, but for the water supply, we can use a UPVC pipes, we can use a PPR pipes, we can use a stainless steel pipes. So these are the options we have. So you know that copper, it's a most expensive material. Stainless steel is a cheaper than copper. PPR, it's a cheaper than stainless steel, and UPVC is the cheapest. So if let's say, for example, there is a 10,000 linear meter of the pipe in the building, and if you are using a copper pipes, and if you are using an alternate material, which is a UPVC pipes, so how much cost difference it will be there? Third one is maintaining a same functionality. So if you're using a copper pipes, you can transport the water. If you're using a UPVC pipes, that also the same function. It's both the pipes are used to transport the water. So that means the functionality, it's the same. You're lowering the cost and you are increasing the value. So this is known as a value engineering. So somebody will ask, if for the copper pipes, if the consultant is asking for the copper pipes, so we have to use the copper pipe for the buildings where it is necessary. I'll give you an example for the hospital works. If you're doing any hospital building, so there you have to use a copper pipes. You cannot use an alternate material for the UPVC pipes. But the copper pipe, if it is there for the residential building, there you can put an alternate material. Like you can put a PPR or you can use a UPVC. You cannot change a copper to UPVC for a hospital building. Okay, so that value engineering also you have to think and place the value engineering, because this thing, it cannot be applied for all the types of projects, because we have so many types of projects. We will have a commercial project, we will have a residential project, and we will have for the hospitality, schools and all. For hospitals, schools, and for many buildings, there the client will not compromise with the value. So there you have to use the same material what like a client is asking, or what a consultant it is asking. But you can propose for the value engineering for those options where the residential or commercial building is there. There you can propose the alternate material. So we'll see later what are the alternate options we can do it for mechanical works. The first one is increasing the value. Okay, so the profit and margin and affordability, I've already explained. This is the client's perspective and this is the customer's perspective. They always need an affordable. As a customer, I need an affordable things, and clients, it should be profit and margin. They need a more profit and margin. Okay, so how you will lower the cost? For lowering the cost, the first thing is design change based value engineering. There's so many types of value engineering you can do. First one is design change based value engineering. In this photo, you can see there is two types of chillers. The first one is the water cooled chiller. The other one is air cooled chiller. So for the water cooled chiller, with the chillers, you should have one cooling tower also. If a mall, it has a 1000 TR, 4 chillers. It should have one cooling tower to cool the condenser. Okay. What you can do is you can increase the number of chiller and you can eliminate this cooling tower. So it's a kind of value engineering which is design based. What a consultant is design is a chiller with a cooling tower. But what you are doing is you are changing a design in order to reduce the cost. For that, you are eliminating the cooling tower and you are increasing the number of chillers. Yes, when you are increasing a number of chillers, you will have some extra cost. But at the same time, you are removing a cooling tower also. So you are having a cost reduction also. So the reduction is more, increasing is less. So that means here actually you are saving your project cost. So total project cost is reduced. The next one is material based value engineering. Like I have given you an example for the copper and UPVC pipes. So the same thing you can do for so many materials. So for so many mechanical items, you can do for the value engineering. The first one is the chilled water pumps. What you can do for the chilled water? Chilled water pumps is used for transporting. It is used for the chiller. Okay, the chilled water pipes. The chilled water has to be transported from the chiller to the equipments. So for that, we are using one device which is known as chilled water pumps, or sometimes it is known as hydronic pumps also. So what is the value engineering you can do is there is two thing you can see is one is the expensive one, the other one is the cheaper one. So the components for the chilled water pumps are casing, impeller, and shaft. Casing, it's a outer body of a chilled water pumps. Impeller, it's a fan, the rotating fan, and the shaft which is connected to your the final product. Okay, so this is what the three components it is there for the chilled water pumps. If a specification it is asking the type, it is vertical type. Casing, it should be a stainless steel. SS, it's a stainless steel 316 or 304. Impeller should be stainless steel 316, 304. Shaft should be stainless steel 316, 304. So these all are the expensive option for the chill water pumps. If I want to propose the cheaper option, what I can do is, in place of vertical, I'll propose the horizontal. In place of stainless steel casing, I can propose a cast iron casing. In place of stainless steel impeller, I can propose the cast iron impeller. In place of stainless steel shaft, I can propose a bronze shaft. Okay, so cast iron, bronze, stainless steel, stainless steel, stainless steel. So if this can be replaced with this, I'm keeping the same functionality. The chill water functionality, it's the same. The same product, the same output, you will get it, but with the cheaper option. Okay, so if you are using this material for casing, impeller, and shaft, the cost of a chilled water pumps is reduced. For like based on my experience, I can say you can reduce like almost 25% of a total cost only for chilled water pumps. The same thing you can do for the ventilation fans also. Okay, the ventilation fan, if it is they are asking for the fire rated ventilation fans, what you can do is you can propose a non-fire rated ventilation fans. Fire rated ventilation fan, it is required only in the basement where the car park exhaust fans and all it is placed. So there you need to give a fire rated fans. If a consultant is asking all the fans in the building, whether it is an exhaust fan or it is a toilet extract fan, kitchen extract fan, they're asking for the fire rated fan. You can propose a non-fire rated fan. Fire rated, that means like if there is any, in case of any fire inside the building and all, this fan will have 2 hours fire rated insulation on top of that. So that means 2 hours it can withstand the fire. Okay, so in place of that you can propose a non-fire rated fan. So there is a difference of almost like 30 to 40% on the cost of ventilation fans. So this kind of material change based value engineering you can propose. The next one we'll see is about the pipes. There is three types of pipes. Okay, the first one is PPR, PN20, PN25. The second one is PPR multi-layer. Third one is PPR multi-layer aluminum cladded. This is the normal PPR. This is the multi-layer, and this is with the aluminum inserted. Okay. So what you can do is, if they are asking for the multi-layer aluminum cladded PPR pipes, you can propose a normal PPR pipes. So there is a difference of almost like 50%. 50% difference it is there between PPR aluminum and PPR normal PPR pipes. So this much value engineering you can do. If there is a 10,000 linear meter requirement, it is there in the entire building. So just imagine if you are reducing a 50% cost, so how much cost you can reduce it for the only for the pipes value engineering, only doing a value engineering in the pipes. The same thing, UPVC. UPVC, it's the cheapest one, the cheapest option which is used in the residential buildings. If it is a residential building, villas, townhouse, warehouse, there easily you can use a UPVC pipes. And mostly in 90 or 95% of the consultant specification, they are asking for the PPR pipes or PPR multi-layer or PPR aluminum cladded. So this all can be changed to UPVC type. So this is a kind of value engineering you can do for the residential building, villas, townhouse, warehouse. Because there this much like the quality of the things, it is not required. You're not doing any hospital projects where you are not you should not compromise with the quality. So there we can use like UPVC pipes normal, which is the cheapest option. So like that, same thing for the ductworks also, stainless steel, black steel, insulated GI ductworks, aluminum ductworks. These are the expensive option. Pre-insulated, non-insulated GI ducts. These are the non-fire rated ductworks. So these all are the cheaper option. The next one is duct insulation. Closed cell elastomeric, rubber, rock wool insulation, calcium silicon insulation. This is all the expensive options. If the consultant is asking this options, so that means it's a expensive option. It is there in the specification. The cheaper one, what you can propose is the mineral wool you can propose. It's known as fiberglass insulation. Phenolic foam insulation. This is also a cheaper option. So these are the cheaper options you can propose for the duct insulations. The next one is hydronic pipes. So generally there is two types of pipes it is used. I hope everyone knows about this. The first one is the seamless. The second one is ERW. ERW is electro-resistance welding. So how the ERW pipes made? First, it is made in the form of sheets inside a factory. Then it will be rolled and it will be welded on the top. So that's why it is known as ERW pipes. Seamless pipes, it's directly a molten metal. It will be introduced inside a die and it will be made in the shape of pipe. So there will be no welding on top of it. So this is what a basic difference between a seamless and ERW pipes, which I have already like explained in my lesson in a detailed way, how the ERW pipes made and how the seamless pipe made. So this is what the basic difference. I'll just tell you. This is what the basic difference between a seamless and ERW pipes. Generally, for the residential building or any building construction work, seamless pipe it is not much required. If it is very super high-rise building, like if it is G plus 100 floor or more than 100 floor building, there you may require a seamless pipe. But for generally for normal residential buildings where you are doing a warehouse or any residential building or any commercial hotel, 5-star hotel or any hotel buildings, you're doing there, you can use normal ERW pipes. But sometimes the consultant may ask only for seamless pipes. There you can change it to ERW pipes. Okay. So ERW is a cheaper option and seamless, it's an expensive option. There is a difference of almost 50% in the price. Current market price in UAE dirhams for black steel pipes, if you're taking for the 20 pipes, it will cost like 14 dirhams. 14 dirhams per meter for ERW black steel pipes. But if if you are using a black steel seamless pipe, it is around like 26 to 27 dirhams per meter for the seamless. So this is only 14 and this is 26. So almost like a difference of like 80 to 90%. So this much cost saving you can do it for ERW, for changing seamless to ERW. So this is also a kind of material change based value engineering. Okay. The last one is unnecessary requirement. I should not say unnecessary requirement. There is some miscellaneous requirement. It should be there for the projects. The first one, what we see is about the design based. The second one, what we see about a material based. The last one is unnecessary requirement, or I should say miscellaneous requirement, which is there in the specification. It may or may not require for the projects, but we should give as a value engineering to the client. Okay, so if the client want, they can accept it. If they doesn't want, they can reject it. So what this kind is, the first one is any spare parts. If you're buying an AC machine, FCU, so the client may ask, I need an additional motor. The one 3-speed motor, it will cost like 350 to 400 dirhams. So if there is 1,000 FCU, it is there in a building. FCU, it's a fan coil units. If there is 1,000 FCU, it is there in the building. So 350 into 1,000, it is around like 350,000. So this much cost saving, you can do it by eliminating this spare parts. Overseas factory visits. Sometimes for the chillers, any big equipments, AHUs, FHUs and all, client may ask for the overseas factory visits. So one of the representative from the client and one representative from the consultant and one from the contractor. This all three together, they'll go to the overseas factory. It can be in Europe or USA or anywhere in the world. They'll go, they'll inspect the chillers, performance, everything. We have to include like 4-star or 5-star accommodation for 5 days in any country, business class flight tickets. So this all cost, it will be associated for overseas factory visits. Okay, and how many people are going? If let's say, for example, 3 people are going to USA from Dubai, so each person, we have to consider the return business class flight ticket, and they'll go there and they'll their accommodation in the 4-star or 5-star hotels, their food, transport, everything. So this all, it's an unnecessary cost. So we can like give the client the suggestion, if they can eliminate this kind of things, we can give this much cost savings. Then extended warranty. Generally, when you're buying a mobile phone, it will have how much warranty? The 1-year warranty. So the same thing for the chillers or any AC machines, it will have a 1-year standard warranty. Sometimes the client may ask for the extended warranty for the 5 years, for 10 years, for 25 years. So this much warranty, like you can eliminate it for the initial stage. When you are submitting the tender, you can give for the to the client the option for the extended warranty elimination. Okay. So these are the things. So I'll just quickly go through it. Radiographic welding test, any stress analysis, the cleaning system, pipe grading, VARA certification for the walls, preferred local or far east product. Like if the client will ask for AC machines to be made only, the country of origin of the machine should be from the US only. So you can propose any local material. Here in UAE, we have Troston, SKM. These are the local products which is manufactured in UAE, and they are much more cheaper than the product which is made in USA. The US brands is Carrier, then they have the Train, Daikin. These are the overseas products. So there is so much cost difference it is there in this kind of brands. So this you can give a kind of value engineering. Any duct heater if it is required, or any leak detection system. So these are the value engineering you can propose to the client. And if you want to learn all this thing in details, this I have covered like in very good way in my lectures. So if you like, you can enroll to our course. And this is all for today. If you have any questions, you can ask.